Welcome to This Explainer. I've been diving into these concepts today, and wow, I am absolutely thrilled to guide you through these blueprints of our future. We're going to be zooming all the way out, starting from the microscopic chemistry right inside our gas tanks, out to the way we navigate our roads, and finally to the grand design of our entire cities. There is just so much incredible ground to cover as we look toward the mid-century.
So, let's kick things off with a staggering number. By the year 2050, forecasts predict we'll hit a massive milestone, close to 2 billion cars on the planet. I mean, that is double what we have right now. And if we double the number of vehicles, we're looking at essentially tripling our fuel consumption. Pulling all that stored carbon from underground and burning it in our engines absolutely threatens to push our climate to an unrecoverable brink.
And this brings us to a pretty harsh realization. We aren't just in a race with other countries to develop cool new tech. We are in a literal race against time itself. The consequences are going to be enormous if we don't radically innovate our way of life and protect the planet.
To see how we get out of this, let's run through our agenda for this explainer. First, the race against time. Second, rethinking our fuels. Third, transforming how we move. Fourth, building the cities of tomorrow. And finally, charting the path forward.
All right, let's jump right into part one, the race against time, and setting the stakes for 2050.
Moving right along to part two, rethinking what fuels us, focusing on the innovations happening right inside the tank.
Even with all the amazing advances in battery tech, we have to face a hard truth. On a weight basis, the sheer energy packed into a gallon of liquid fuel is basically unparalleled. We are not going to see heavy, long-haul trucks running on batteries anytime soon, and we definitely won't see electrified commercial airplanes yet. So we'll absolutely still require dense liquid fuels. But the way we currently make alternative fuels, the contrast is fascinating. Take the US, for example. Producing ethanol from corn is basically a one-to-one energy return. For every unit of energy you put into growing and processing the corn, you get about 1 unit out. You barely break even. But then look at Brazil. Because of their climate, they can use sugarcane. And their process is a total model of efficiency. They extract the sugar, ferment it with natural yeast, and even burn the leftover plant matter for heat and electricity. The result? They get out 7 times the energy they put in, which slashes the total carbon footprint by up to 70% compared to regular gasoline.
But here's the catch. We only have so much arable land on Earth. We can't exactly turn the whole planet into sugarcane farms without destroying critical natural areas like the Amazon, or, cutting into the global food supply. So, synthetic biologists are doing something that is literally mind-blowing. They're looking at native, super hardy weeds like switchgrass that grow on terrible land without much water. Step 1, they extract glucose from this tough plant matter. Step 2, they feed that glucose to genetically engineered yeast. It's kind of like brewing beer, right? But instead of making alcohol, this custom yeast changes the sugar's chemical composition and excretes high-energy hydrocarbons. Step 3, these fuel molecules just float to the top, you skim them off, and they go straight into your tank. How cool is that?
Now, let's take this to an even simpler yet profoundly futuristic level. For materials chemists, artificial photosynthesis. Imagine if we didn't have to grow crops for fuel at all. Just picture a material that looks kind of like bubble wrap that you can just roll out. Sunlight and water go in, a catalyst, something like iron or nickel, does the heavy lifting, oxygen vents out, and the material physically wicks out a liquid or gaseous fuel that you can easily collect and use. It's a total game changer.
Okay, zooming out from the chemistry in the fuel tank, let's shift gears into part 3, transforming how we move.
We all know that soul-crushing emotional toll of a terrible commute, right? But the raw data is just wild. The average American spends nearly 300 hours a year inside their car, and 38 of those hours entirely stuck in gridlock. And financially speaking, that inefficiency burns through over $1 billion in wasted fuel annually just in the US alone. It's a massive drain on our time, our wallets, and of course, our climate.
So, to cure this unbelievable congestion, developers are totally rethinking how vehicles see the world using next-gen digital mapping. They are outfitting mapping cars with LiDAR, sonar, and 360-degree video. They use 64 rotating lasers to build a 3D point cloud of the real world, collecting a staggering 1.3 million data points every single second. In the near future, your car's routing isn't just going to look for the shortest line on a map. It's going to route you based on real-time traffic density, the exact timing of stoplights, and even your battery's current charge level to guarantee you get there using the absolute minimum amount of fuel possible.
Now, when you marry these hyper-detailed 3D maps with autonomous driving tech, you unlock this awesome concept called platooning. Just like racing cyclists who draft tight behind each other to save energy, trucks can use wireless communication to drive incredibly close together. If the lead truck hits the brakes, that message transmits instantly and all the following trucks brake autonomously at the exact same millisecond.
The crucial point here is the massive financial and environmental payoff. At highway speeds, a truck uses more than half its energy just pushing the air out of the way. By platooning and drafting off the truck ahead, air drag plummets. Cutting that drag by just 10% translates to saving roughly 8,000 euros in fuel per heavy-duty truck every single year. Multiply that across entire global fleets, and the savings are absolutely astronomical.
Let's zoom out one more time to the macro level for Part 4, Building the Cities of Tomorrow.
Let this fact sink in for a second. Every single week, the equivalent of a brand new city of 1 million people is built somewhere in the world. We are urbanizing at a terrifying speed. What this means is that the old 20th century model of the energy-hogging, car-centric city is completely dead. We just can't keep paving over the planet with wide asphalt roads that bake in the sun and demand endless air conditioning.
To see what the alternative looks like, look no further than Abu Dhabi. On one side, you have the downtown area, wide black asphalt streets, mirrored reflective glass buildings, and a surface temperature baking at an insane 57 degrees Celsius. But right next door, just outside Abu Dhabi, is a prototype urban center called Masdar City. Here, the ground temperature drops to a really comfortable 33 degrees Celsius. How? Well, they looked back at ancient Arabic architectural tricks to move forward. They hid all the cars in transit completely underground, leaving the street level entirely for pedestrians. By pushing the buildings much closer together and elevating the walkways, they create permanent shade and naturally capture cooling breezes.
And this perfectly shows the real-world impact of smart design. By simply designing a city for humans instead of for cars, and using modern shade screens to prevent direct sunlight from hitting glass, they've naturally cooled the entire environment. This slashes the city's air conditioning needs from a 100% baseline down to just 40%. That's a massive 60% energy saving, achieved purely through intelligent, location-aware city planning.
Of course, Masdar still needs power to run. Because standard silicon solar panels are pretty expensive, they're testing this incredible prototype called the Solar Beam Down. First, they use a massive field of highly reflective mirrors on the ground to bounce the sun's rays up to a central tower. Second, that beam is directed right back down to a single hyper-focused point on the ground, superheating it to 600 degrees Celsius. Finally, all that intense heat generates steam, which spins turbines to create clean electricity.
Which brings us to our final section, Part 5, Charting the Path Forward. How do we actually take all these micro and macro innovations and apply them to the real world?
As researchers step back and look at all this data, a really profound philosophical point emerges. Humanity is adventurous, sure, maybe a bit vain, and definitely wildly ambitious. But by accepting our place in this world, we've also accepted a sacred trust. We have a profound responsibility to sustain the Earth. And taking that responsibility seriously is not always going to be easy.
So how do we apply this blueprint? Well, we have to treat utopian projects like Masdar not as perfect, finished products. I mean, they still rely on natural gas at night for now, but as global laboratories. We have to apply localized solutions. The cooling tricks of Masdar won't work in freezing cities that desperately need to let the sun in, but the core principle of designing for your local environment, that is universal. We need to rebuild our infrastructure ahead of this massive urban demand, and above all, we need to invest heavily in basic research immediately.
The truth is, we aren't waiting on magic here. We literally have the synthetic biology to engineer our fuel, the 3D maps to perfectly route our roads, and the architectural principles to organically cool our megacities. Which leaves us with one vital final question. We know exactly how to build the future, but do we have the collective will to actually live in it before time runs out? Thank you so much for joining me on this explainer. I really hope it gave you a completely fresh perspective on the road ahead to 2050.